If you've seen the images coming out of the James Webb Space Telescope, you probably have some sense of why you should care about them. They are, very simply, stunning. There are sparkly stars, majestic clouds of gas and so many galaxies. To learn more about what these images mean for scientists and what we can all expect to see next from the JWST, I spoke to Katie Mack, a cosmologist at the Perimeter Institute and the author of The End of Everything, Astrophysically Speaking. Our interview has been condensed and lightly edited for clarity. Hannah Dr. Loeb, how's JWST different from previous telescopes? It's about 100 times more sensitive than the Hubble Space Telescope. It's got a much larger mirror. This means that it can gather more light and see dimmer objects in the very, very distant universe. It's also working with different wavelengths. Hubble was visible light and a little bit of infrared. JWST is all infrared and goes much farther into the infrared part of the spectrum. That gives it unique capabilities. For example, it's able to peer through gas and dust clouds. It's able to see the gas and dust in things like the cores of interacting galaxies. It's also able to look at much more distant objects. It's really optimized for both the distant universe and for things like the star-forming universe. It's able to see essentially some of the first galaxies that ever were formed in the cosmos because it can look back more than 13 billion years. I keep hearing the term gravitational lensing. What exactly is that? The first image that was released was this image of a galaxy cluster called SMACS 0723. The main thing you see when you look at that image is that it's just full of galaxies. There's a cluster of galaxies at the center, large elliptical white, fluffy blobs. There are a couple of bright stars, and there are a lot of galaxies sprinkled around. The thing that jumps out at you is that there are these streaks, these smudges and arcs, circling the central cluster. Those are actually images of very, very distant galaxies behind the cluster, far in the distant universe, whose light has been bent and distorted by the gravity of that cluster of galaxies. When there's a massive object in space, it bends space around it. In that bending, it creates a kind of distortion, where light then doesn't travel in a straight line. It bends around the object, and that bending can magnify the images of objects behind whatever massive thing is doing the lensing. In this case, it's a cluster of galaxies. It can also happen with black holes, with individual galaxies, even sometimes with stars in very specific kinds of circumstances. Gravitational lensing effect basically means that this cluster of galaxies is serving as a lens to both magnify and distort the images of very, very distant galaxies. I've also been hearing about controversy around the name of the telescope. Can you explain that? The telescope is named after a NASA administrator who was head of NASA during a time when there was a lot of anti-LGBT discrimination, and there's evidence that he was involved in that. It's a strange thing to name a telescope after an administrator anyway, and the choice was a unilateral decision by NASA higher-ups. There was no input from the community on that. As many members of the community have been speaking up and really objecting to the name, those concerns have not been addressed at all. I've been trying to refer to it by the initials in recognition of the fact that the name itself is problematic. But it's still in my head as Webb, because that's what it's called by NASA. I slip up sometimes, but I'm trying. There's been an effort within the community for a lot of people to refer to only by initials. A lot of people are feeling very excluded, very ignored, and disrespected by that whole process. Science is a human endeavor, and NASA keeps talking about how science is for everybody. I think that, if we take that seriously, then we need also to take this seriously, the concerns of people who are feeling excluded and disrespected by the decisions that NASA made around this project. Back to the images themselves, was there anything from this that surprised you at all about the first image that was released, of the galaxies? The level of detail and the number of objects, and just the clarity are really, really striking, and very moving in a way. You look at this deep field image, the image of the cluster, and you can just scroll around, and you see all of these galaxies in little spiral galaxies, little elliptical galaxies, little smudges of weirdly shaped galaxies. You're looking at images of galaxies that no human ever saw before JWST, these pictures. And every one of these galaxies is a collection of millions or billions of stars, like our own Milky Way. Do you have a favorite image so far? That cluster image is probably my favorite, just because of the variety of galaxies and the depth of which you're seeing the cosmos. But the other one I was really struck by was the image of the Carina Nebula. This is a star-forming nebula, where it's a cloud of gas and dust, in which little knots of that gas and dust are collapsing together, compressing to form new stars. JWST took a couple of images of a piece of this nebula with different bands of infrared light, and looking at this picture is just really moving, because you can see these tendrils of dust and gas, and you can see the tiny pinpricks of new stars forming inside these clouds of gas. It's the kind of environment that our star, the Sun, was formed in billions of years ago. What happens next with the telescope? The JWST is going to keep taking data. All the stuff that we're seeing was a result of about 5 days of observing. This is just the first week. Apparently, the telescope has fuel to last for decades. It can keep taking data as long as it keeps functioning well. So we're going to see more incredible images. Hopefully, we'll get to learn about the atmospheres of planets around other stars, maybe planets that are more like Earth. It's possible that we'll be able to see spectra of other planets, which could tell us something about the atmospheres of planets, maybe similar to Earth, orbiting other stars. This is just the very beginning. I think JWST is going to really change a lot of things that we know or think we know about the cosmos.